These are the lecture notes for Chapter 2 on chemistry. And just to let you know, Chapter 1 probably made sense to you because it was an introduction chapter. There was a lot of medical terminology in it. Now we're going to have Chapter 2 on chemistry and Chapter 3 on cells. So just to let you know, the purpose of that is to give you a review of those topics, especially a lot of this information ends up showing up on the TEAS test. And not every one of you, but probably maybe every one of you, a lot of you end up taking the TEAS test because Bio 163 is what is required for the LPN program. So you will have to take that TEAS test. And these next two chapters are real important. So that's why we don't skip them in anatomy. It's not even in the summer. Okay, so we have the learning outcomes listed. I think I'll save us some time and just move on. The study of chemistry is defined as the science that investigates matter and its interactions. So you really have to know what matter is. Anything, and you learn this as a young child in elementary school, it's anything that takes up space and has mass. So takes up space means volume. Mass is the amount of matter an object contains, and we typically measure mass in grams or kilograms, milligrams even for small amounts. And then we typically measure volume in milliliters in biology. Sometimes we'll talk about in terms of liters, like when we are talking about the amount of blood pumped by the heart, per day, that kind of thing. We'll use larger volumes like liters, but milliliters would be for smaller volumes. Matter is composed of substances called elements, and these are the purest substances that there are. They're all listed on the periodic table of the elements. Examples would be oxygen and carbon, which, and they all have symbols. Sometimes it is the first letter of the element's name, sometimes not. But for oxygen, the symbol for oxygen is O. And the symbol for carbon is C. All right, inside of an atom, you have three what we call subatomic particles. Atoms are the smallest units of elements. So atoms are also pure substances. They're the smallest particle of an element. They contain protons, neutrons, and electrons. The protons and the neutrons reside in the nucleus. Notice in this atomic model for helium, there are 2 protons and 2 neutrons in the nucleus. And the electrons reside outside the nucleus. And there are 2 electrons outside the nucleus in this helium atom. Now, the neutrons do not have a charge at all. They have a neutral charge. Protons have a positive charge and electrons have a negative charge. So what do you need to know about these subatomic particles? You need to know their charge and you need to know their location, whether or not, like protons and neutrons are located in the nucleus and electrons are located outside the nucleus. Okay? On the periodic table, you're going to have a symbol and you're going to have some numbers. The atomic number for all of the atoms, the atomic number is the smaller number in the box. And it is telling you the number of protons in that atom because the number of protons will never change. So all helium atoms contain 2 protons, for example. Isotopes are atoms of the same element that have different mass numbers. Some isotopes give off radiation, and they're called radioisotopes. We use technetium-99 for nuclear scans. We use iodine-131 for iodine scans. So these are radioactive isotopes of these particular elements. So the atomic number is the number of protons. The mass number is the number of protons plus neutrons. There's a section in here on atomic weight I'm going to skip. Electron shells. So every atom has at least one shell around it. So if this is the nucleus, ugh, that's not going to work. It's going to keep doing that. Okay, so I'll just draw an X in the center. Okay, so here we go. If this is the nucleus of the atom, okay, the first electron shell is full when it has 2 electrons in it, just like helium, okay? This first electron shell is full with 2 electrons. And helium is considered a stable atom. It will not form chemical bonds with other atoms because its outer electron shell is already full. But if you have more electrons, the extra electrons besides those first 2 will go in electron shells that are outside of the first one. So those, after the first electron shell, the ones after that are filled with 8. 8 electrons, it takes 8 electrons to make that outer shell completely full. So this is the rule of how it works. The way that electron shells fill is that the first shell fills first, and it's the one closest to the nucleus, and it holds only 2 electrons. The second shell and every shell after that holds up to 8 electrons. Because, you know, some of the atomic numbers are in the hundreds or like the high 90s, and that means they have that many protons. And since electrons and protons are always equal in a neutral atom, then that's going to be a lot. So you just kind of have to keep placing the electrons in energy shells or electron shells until each shell has 8, and then the outer shell has as many as it will hold after that. So looking at some examples, this is carbon. All right, carbon's atomic number is 6. So in the periodic table, it would have a C for its symbol, and then it would have atomic number 6, and it would have mass number 12 point something, okay? So what we would do with those numbers is we could take the 6 and we know that there are 6 protons, because that's what the atomic number means. So there's 6 of these protons in here, although you can't see them all. And then there's going to be 6 electrons, because the protons and the electrons have to even out, because the protons are positive, the electrons are negative. So, and there's 6 electrons total, 2 in the first energy level, 4 in the second. For neon, it's got 2 electrons in its first energy level, and it's filled up with 8. Neon is another one of those noble gases that is chemically stable and won't combine with other atoms. So the carbon, which only has 4 electrons, is going to have to find some way to fill up this outer shell. That's what atoms are trying to do, is they're trying to become stable. So they're trying to somehow, some way, through some kind of chemical bond, they're trying to fill up their outer shell. Okay? So atoms interact with each other to form larger structures, molecules. They can share electrons, gain electrons, or lose electrons through chemical reactions. And that causes them to form chemical bonds. Chemical bonds are a strong attraction between atoms that holds them so closely together that they become a totally different substance with different properties. Chemical bonding forms molecules and compounds. Now, there's a slight difference in the definition of a molecule and a compound. Both of these, oxygen, which has 2 oxygen atoms chemically bonded, and water, H2O. Both of these are molecules, but you don't see oxygen in the list of compounds because oxygen is a molecule but not a compound. But water is a compound. So really, the way that I tell them apart is that all compounds are molecules, but the molecules that are only composed of one type of atom are going to be just molecules. They're not compounds. A compound has to have at least 2 different atoms in it. Okay? Then we have ions, and ions have a charge. That means they've lost or gained electrons. Okay? So if it's a cation, it has a positive charge because it has lost an electron. If it's an anion, it has a negative charge because it has gained an electron. Since electrons are negative, then if it gains an electron, it will gain a negative charge. But if it loses an electron, it will gain a positive charge. So an example of a cation, they probably got some on this next page. An example of a cation is a sodium ion, and which is written here. And an anion is a chloride ion. This is an anion. Okay, so positive is cation, negative is anion. If it's a cation, it has lost electrons. If it's an anion, it has gained. All right, the strongest, no, I'm sorry, it's not even the strongest. I was about to say something wrong, but I didn't. Almost did. One type of chemical bond, which is actually weaker than a covalent bond, but one type of chemical bond is called an ionic bond. And what happens is ions that form opposite charges, like a sodium ion has a positive charge and a chloride ion has a negative charge. These ions are attracted to each other because opposite charges attract. So they will be joined together, and that is called an ionic bond. Okay, so what has to happen first is the sodium has to lose an electron and the chloride ion has to gain an electron. So what does sodium and chlorine look like before they lose one and gain one electron? Okay, so first, sodium has an atomic number of 11. Okay, so that means the first 2 electrons go in the first shell, 8 go in the second shell. That comes out to be 10. Then there's 1 in this third energy level, this third shell. So if sodium were to lose that, and that means it would take on a positive charge like it does here, if sodium were to lose that, it would actually lose that third shell as well because there would be no need for it, and it would have a filled second energy level or second electron shell because this second shell is filled with 8 electrons. So when it loses this 1 from the third electron shell, it takes on a positive charge, and it loses it because so that it will have a filled or complete outer energy level. Now the chlorine has 7 electrons in its outer electron shell or energy level. So if it were to gain 1 more, which it could get from sodium, if it were to gain 1 more, it would take on a negative charge. And because it had gained that 1 electron, and now its outer energy level is complete. So now that the chloride ion and the sodium ion, I just don't like the way that looks. Now that they have opposite charges, they're attracted to each other because opposites attract. And now they bond, they form an ionic bond, and they become sodium chloride. All right, better. Okay, then covalent bonds are formed by the sharing of electrons. If you have a single covalent bond, that's the sharing of 1 pair of electrons. A double covalent bond is the sharing of 2 pairs, which is 4 electrons. these two oxygen atoms are sharing a total of 4 or 2 pairs of electrons.